Hey guys, I'm Ziyuan, and today I'm going to introduce my project, which is the Argand Diagram. So before we know the definition of the Argand Diagram, we have to know that what is the complex number. So the complex number is a number that can be expressed in the form of a plus bi, where the I is the solution of the following equations. The equation is the x power 2 is equal to minus 1, which means the I is equal to the square root of minus 1. And the complex number is denoted by the C. So the Argand diagram is a diagram that representing the complex number in the graph form. And it is named after the gene report Argand. So look at this picture. The y-axis is the imaginary axis, and the x-axis is the real axis. And so our line, our point is a plus bi, so where the a is the real part and the b is the imaginary part. So what is the modulus? So the modulus is the distance from the original point to the point you have signed. And it is denoted by r, and it is equal to the absolute z, and it is equal to the square root of x power 2 plus y power 2. And look at the picture at the right side. So the r is the distance from the origin to the point. And here's an example below, which is to find the modulus of z equals to 8 minus 15i. So the modulus is equals to the square root of 8 power 2 plus 15 power 2, and it is equal to 17 finally. And then here's the fact that the z, if the z is equal to a plus bi, the z bar means it has a negative imaginary part, which is a minus bi. And so the real part of z is equal to x, and it is equal to the z bar plus z bar over 2, and the imaginary z is equal to y is equal to z minus z bar over 2. And here's another fact that the z, the square of the absolute z is equal to z times z bar. So here's an example to find the locus of the z that satisfies the absolute z bar minus 3 plus 3i is equal to 4. So how we solve this? Firstly, we let the w equals to the values inside the absolute value. So it w is equal to z bar minus bracket 3 minus 3i, which means absolute w is equal to 4. So we will get the absolute value of x minus yi minus the bracket 3 minus 3i, and we transfer it to the normal form, which is the a plus bi form. So the real part will become x minus 3, and the imaginary part will become 3 minus y. And it equals to 4 finally. According to the definition, the modulus will equal to the absolute value of this x minus 3 plus 3 minus yi. So we will find that the x minus 3 power 2 plus 3 minus y power 2 is equal to 16. So which is a circle that has a center of 3, and its radius is 4. So then we have to understand what is argument. The argument is the angle from the positive axis to the line. And the phi is equal to argument of x plus yi if the x is greater than 0 or the y is not equal to 0. It is equal to 2 arctangent y over square root of x power 2 plus y power 2 plus x. And So if the x is less than 0 and the y is equal to 0, the argument of x plus y will be equal to pi. But if both of them are equal to 0, the phi does not exist. So the argument is found from the rectangular form xyi by applying the inverse tangent, which is arctangent, to the quotient of the imaginary by real parts. So here's another example. To find the locus of the point z, that argument of z is less than or equal to pi, but greater than or equal to pi over 4. So let's sketch the graph first. So the locus we needed is at the left part to the line, and the line makes 45 degrees to the positive x-axis. So let's go through another example, which is to find the argument of 2 plus 2 times square root of 3 times y times I. So similarly, we sketch the graph first and we calculate the modulus. The modulus is equal to the square root of the 2 power 2 plus 2 times square root of 3 power 2, and it is equal to 4 finally. And we can find the tangent theta as well, which is equal to the imaginary value over the real value. So it is 2 times square root of 3 over 2, which is square root of 3. So the theta is the pi over 3. Also, so the next is the trigonometric. So the next is the trigonometric form, which is z equals to r times the bracket cosine theta plus I sine theta, where the r is the modulus and theta is the argument z. So from the picture, we can see that actually it just changed the y part, the imaginary part equals to the r times sine theta, and the x is equal to r times cosine theta. So it can be changed to Euler's formula as well, where the like the picture shows, where the e power I theta is equal to cosine theta plus I times sine theta. So the z will be equals to r times e power I theta. So it is also called the exponential form as well. So look at this picture. Shows this Euler's formula. Okay, thank you. That's the end of the topic.